How many times a week do you fill up your car? Once a week? Twice? Maybe more? Well, imagine what it would be like to fill your car not with gasoline, but with electricity. And imagine that your electric car is not only stylish, but aerodynamically efficient. It runs clean. In fact, there's no exhaust system. Your electric car is comfortable. It's even equipped with air conditioning. And it's no slouch on the open road either. It'll do 0 to 60 in 8 seconds flat. Just imagine. Recently, a team of innovative GM designers, engineers, and technicians did just that. But they not only imagined such a vehicle, they created one. It's called Impact, and it's creating quite a stir.
We are extremely pleased this morning to be able to introduce to you a project that keeps GM on the cutting edge of technology. It's called Impact, and it's an exciting new electric car, the first one in 10 years. It can go further and faster than any previous production-oriented electric vehicle. It can go from 0 to 60 miles an hour in 8 seconds, and it has all the comforts and convenience of a modern automobile.
I thought it was a very interesting vehicle, very interesting concept. I like the fact that it's the first time they've gone through and done the engineering that needs to go with a production electric car.
It seemed very smooth and terribly fast. I was able to accelerate quite quickly.
Well, after getting out of it, I'm very impressed with the smoothness and the acceleration of the car. I'm normally accustomed to the internal combustion cars, the Camaro and the Corvettes, and I was really impressed. I think there's a definite future for the electronic car.
I think the acceleration is reasonable. In general, cars are performing more and better in the last few years. And this car, surprisingly, would be competitive, I think, with most performance cars available today.
The Impact was built first as an engineering test vehicle where advancements in electronics, structural materials, motor design, tires, and batteries could be tested.
Well, it was a kind of an outgrowth of the Sun Racer project that was done by General Motors, and the fact that we won the race in Australia in '87 by some 2.5 days gave us a strong feeling that we had a pretty good lock on some technology. And so it looked like a kind of a good evolution to examine a pure electric car. We wanted to kind of drive a stake in the ground, if you will, as to what contemporary thinking but producible electric vehicle would look like and how it would perform if we were to build such a vehicle.
Previously, a lot of electric cars have been done by converting a production car, which is certainly an easy way to do it, but the trouble is you end up having to make a lot of compromises in doing that. The production car was not designed for the ultra-low rolling resistance, the good aerodynamics, and so by the time you're done, you've made so many compromises that you don't have a viable car anymore. So the approach here was to take a clean sheet of paper approach to an all-new car.
The Impact is distinctive in a lot of ways. It's front-wheel drive, but there are 2 motors, one for each wheel. The gross weight checks in at a little more than 2,500 pounds, with 870 pounds belonging to its battery pack. The Impact is equipped with rack and pinion steering, specially designed radial tires, and a single-speed transmission, no shifting. As the design of the Impact began, several key objectives helped to form the challenge facing the team. Earlier attempts to produce a viable electric car were met with concerns about driving range and complaints about performance and style. But from the very beginning, Impact was going to be different. To achieve a cruising range of over 100 miles per battery charge, the designers of Impact were charged with creating the maximum in aerodynamic efficiency.
Well, we set targets for each one of the systems in the car from an efficiency standpoint, and the aerodynamics of the car, its drag coefficient is 0.19, and that's about half what current vehicles are, passenger car vehicles. And some of the things that allow you to do that with an electric drive, there is no drive shaft down the center of the car that you have in, say, in a rear-wheel drive car. There's no exhaust system. So the underneath of the car can be very clean and smooth. As a matter of fact, it has a complete belly pan underneath the entire car. That makes it very aerodynamically smooth. and attention to every detail in the car. The car is 9.5 inches narrower in the back, and so it has kind of a teardrop shape to it, a very contemporary feel to it and look.
Any aerodynamic shape would have a tapered surface going from front to back, and what the objective is to have as small a base area as you can. The smoother you can do that, the better chance you've got of lowering the drag on a vehicle. So it's an important element.
In this car, the drag is very, very important compared to a gasoline car. With our large battery pack in there, we have the equivalent energy of about a gallon of gasoline. So you can see that it's like trying to make a car that gets 100 miles per gallon. So we have to push on efficiency everywhere we possibly can.
Each thing that you put on the vehicle in terms of a feature that may consume power reduces the range of the vehicle. So each system, again, has to be optimized. So we have an air conditioning system that's going in. It's it's an electric motor-driven compressor, and we have the most efficient motor design that we know how to make driving that compressor. So each aspect of the car is optimized, because this car is not forgiving. When you use up the power, it impacts the range of the vehicle, and range is a large concern to us from a customer acceptance standpoint.
Testing